This is section 1-2, and we're going to talk about properties of real numbers. Like we've done before, make sure you have your note sheet available with you and in front of you as you're watching this video as we go through some things. This is kind of a short video. It's a short section because properties of real numbers you've talked about at the beginning of probably every math class since you started taking algebra, probably going back to grade school. Okay, so we're going to review sets of numbers, we're going to review properties of real numbers, and I'll give you a chance to do some practice with that, identifying both sorts of things on your own, both in this video and in your textbook, and then we'll go from there. So we'll start with different sets of numbers. So you see on your note sheet, there's all these boxes and things. Hopefully you're getting that. You can see that on the camera. I'm holding it up right. Fill that in with me. I kind of made it animated on here just to go through the different sets of numbers and how they react or how they are related to one another based on what numbers they have in common. So the smallest set of numbers we have, it's the first set you really learned when you were a little baby and you started learning how to count. These are called the natural numbers. Another name for them, like I just kind of alluded to, is the counting numbers. They're the numbers we use when we count things. 1, 2, 3, 4, etc., etc. Okay? Now, interestingly enough, in the history of civilization, you'll notice there's a number there that's missing. And actually, there are civilizations that didn't know the concept of this number. It wasn't until the Mayans discovered it that we came up with another set of numbers that the naturals fit in. And that's called the whole numbers. And the number that I'm referring to, of course, you can see in bold in this bigger box, is 0. So there's your little history lesson for this video. Not every civilization knew the concept of the number 0. And that's why we actually have to differentiate between the natural and the whole numbers. Okay? So now you might be asking yourself, all right, well, we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all and so on and so forth. What's the next bit of numbers we're missing? The negatives. So when we take these whole numbers and we put their negative counterparts in with them, we get a bigger set of numbers called the integers. Notice too in parentheses you see the N for the naturals, the W for the whole, the Z for the integers. These are just abbreviations that we use, so feel comfortable with that. Your book uses them, so that's why I put them in here. Interestingly enough, we don't use I for integers. We actually use the letter I for something else, which we're going to talk about later on this school year. We use the letter Z. I think it's because the word for integer in German starts with a Z. I think that's why. I'm not sure if it's German. It's another language. Integer in another language starts with the letter Z, so that's why we use it. All right, so we've got our integers. We've got our negative numbers. We've got 0. We've got our positive numbers. Now what's missing? The not-so-nice looking numbers, huh? The fractions, some decimals. So that's our next set. And you probably know what that's called. The rationals. Again, we don't call it R. Something else is going to be referred to as R. Q is the abbreviation for the rationals. Okay. Instead of giving you a list, I gave you a definition at the bottom of that box. This is what it means to be a rational number. It's any number that can be written as a fraction. So 0.5, that's a rational number because we can write it as 1/2, 1 over 2. Negative 11 is a rational number. That's negative 11 over 1. The square root of 9, well, that's just 3, or 3 over 1. So that's a rational number. Okay, now if you look at your box on your note sheet, you'll notice there's that box to the right. Nothing fits into that, and that's the next set we're going to talk about. So naturally, you're probably saying to yourself, and you've seen this already, so this is not a stretch of your imagination, what about stuff that can't be written as a fraction? Well, that's a different set of numbers called the irrational numbers. Okay? Any number that cannot be expressed as a fraction is irrational. Another way to describe an irrational number is a number that is a decimal, which does not repeat, nor does it ever end. Perfect example is pi, 3.14159, ... Some of you in grade school may have done memorization contests where you can memorize 100 decimal places of pi. It never stops. That's what makes it irrational. Square root of 2 is another example. If you put the square root of 2 into your calculator, it's going to cut off the decimal, but realize it keeps going. It's an irrational number. And then negative square root of 7 is another example, just to show you that positive number, or irrationals don't have to just be positive, they can also be negative. All right, so all of these numbers now are real numbers, or just R is what we use. Okay, so these are all the different sets and subsets of real numbers. Should be a review. All right, let's just practice. There's 3 examples on your sheet. What am I? So I'm going to say one. It's on your sheet. Take a couple seconds, pause the video, see what you think. There's going to be more than one right answer. Try to get them all, and then pick it up, and I'll give you the answers. So the first one is negative 23. So pause, take a guess, and push play again for the answer. Okay, negative 23 is an integer, because it's negative, a rational, because it can be written as a fraction, and then a real. Real is almost always going to be an answer. All right, let's look at the next example. The square root of 50. Okay, so that is an irrational number, because the square root of 50, if you put it in your calculator, you won't get a terminating decimal. Basically, anything that's not a perfect square is going to be an irrational number. And then again, a real. Everything's a real. All right, last example, negative 7/8. All right, now be careful about this one. It's only a rational number because it's a fraction, and it's a real number. It is not an integer. The negative, I threw a negative in front of this for a reason. Negative doesn't mean integer. Integers are only the whole numbers and their negatives, not negative fractions. Okay, so just rationals and reals. All right, so one more thing I want to talk about is the properties of real numbers. You have another table. Here's what I would suggest doing. Pause the video, copy this down, and then I'll talk about it. Okay, hopefully you've copied this all down. Let's go through, again, review for you here. So the first row is the commutative property. You may have heard this mentioned as the order property. And all this means is if you add 2 numbers or you multiply 2 numbers, the order that you do the addition or multiplication doesn't affect your answer. 2 times 3 is the same thing as 3 times 2. 1 plus 5 is the same thing as 5 plus 1. Okay? Its cousin is the next row, the associative property. This is when we're dealing with adding 3 or more numbers. Technically, we can only add a pair of numbers or multiply a pair of numbers at a time. So we've got to use parentheses to tell us which we're going to do first. Remember from the last section, order of operations, parentheses was the first thing we always had to look out for. Associative just says it doesn't matter where you put your parentheses. If you're adding a bunch of numbers or you're multiplying a bunch of numbers, you're going to get the same answer. All right, the third row is the identity. For addition, that number is 0, is the identity for addition, which means it's the number that when you add it to anything, you don't change the value. 3 plus 0 is 3. Negative 7 plus 0 is still negative 7. Pi plus 0 is still pi. For multiplication, there's a similar property at work, but you use a different number. Notice it says a times 1. So we do a times 1, and we'll keep the identity of whatever number we were multiplying by. 8 times 1 is 8. Negative 11 halves times 1 is negative 11 halves. Okay? Now, a kind of related property to that one is the inverse in the next row. I kind of put these in order for a reason. There's a method to my madness of how I constructed this table, because each kind of goes hand in hand with the one next to it, at least for the first 4 rows. So inverses kind of go hand in hand with identity. Why? Because when you add a number by its inverse, you get that 0 identity element back. What is an inverse? Well, it's just the opposite sign for addition. A plus negative A. 8 plus negative 8 is 0. Okay? Multiplication, the inverse isn't the negative, but look what it says. It's 1 over A. Does anybody remember what that word is called when you put 1 over something? It's called a reciprocal. So if you multiply any number by its reciprocal, you get a 1 back. 3 times a third. 4/5 times 5/4. Okay, inverse property. The fifth row there, closure. All that means is if you add 2 real numbers, you have to get another number back. If you multiply 2 real numbers, you have to get a real number back. Okay, and the last is the distributive property. And the distributive, if you notice, it kind of goes across both the addition and multiplication column. It's because we're using both properties. You're doing a number times a sum in parentheses is equivalent to just taking the number outside the parentheses and multiplying it by what's inside the parentheses separately, AB and AC. Should all be a review for you, okay? Now let's just practice identifying properties, so kind of like we did in the last section. I'll give you an example, and then you'll guess what the property is using the table, and then I'll replay the tape, and I'll give you the answer. All right, so here's the first one. Parentheses 6 times 8, close parentheses, times 7 equals 6 times parentheses 8 times 7, close parentheses. So pause, guess, and then push play. All right, this is the associative property of multiplication. The parentheses should be a dead giveaway there. When you see parentheses and one operation, all multiplication or all addition, you're thinking associative. Okay, don't be confused with the distributive property. That would be if there was both addition and multiplication in the problem. All right, next one. Okay, hopefully you just listened to what I just said. This does have parentheses, but there's multiplication and addition, so it's the distributive property. All right, let's look at the last one. All right, so if we look here, we've got 12 sevenths and 7 twelfths multiplied together to equal 1. Well, a couple ways I think of this. I'm seeing two things multiplying to equal 1. So that's one example or one giveaway that it's an inverse, multiplicative to be exact, because it's multiplication. The other giveaway is that 12 sevenths and 7 twelfths are flip-flops. They're reciprocals of each other. And we just said in the last slide, when you multiply something by its reciprocal, that's called the inverse. Okay? Easy stuff, right? Review. I'm hoping this is not new material for anybody because you should have done this in Algebra 1, maybe even back in, like I said, grade school math. All right, so just to give you a little bit of chance to practice, on page 14 of your textbook, do numbers 18 to 34. If you want, if you printed out these notes, you could do them on the back of the sheet, do them in your notebook. I'll be checking them. It's just more of the same kind of stuff, identifying sets, identifying properties. We'll go a little bit deeper in class. If you have any questions, be sure to bring them to class. I'll go over the answers to these as well in class. And with that, have a great evening.